for uniform distribution, so uniform distribution, we actually have to take a step back to compare the difference between a discrete random variable, so discrete random variable versus continuous random variable. So what is the difference between discrete and continuous? So use another word. Discrete means countable, and continuous means not countable. So one really good example that I use all the time is, so every time you think about the word discrete, think about a few individual dots. Why do I use dots? Can you count how many dots are on the screen right now? The answer is 6. You can use your finger to count, right? So what about continuous? For continuous, think about one line. How many dots do you see right there? The answer is there are infinitely many. Or you can say that I am not able to count the number of dots. So since I am not able to count, to do the best I can use a ruler to measure the length of this line. So that is continuous. It's not countable, but measurable. I cannot count, I have to measure it. All right. So for continuous random variable, actually we have to do some review. So still remember this. So let's say I ask you to graph the linear function f of x is equals to 2x plus 1. What is the graph look like? The graph looks like this, right? So we have an xy axis. The y-intercept is at 0, 1. And then the slope is 2, right? So slope is equals to 2. The y-intercept is 0, 1. What about f of x equals to let's say negative 2x plus 3. So this will be the y-intercept is at 0, 3. And then what is the line look like? Since the slope m is equals to negative 2, the line is going downhill like this, going downhill. What about f of x equals to 2? What is the slope? The slope is 0x plus 2. So slope is equals to 0. When the slope is equals to 0, what is the line look like? The line is horizontal. So that is the same thing as saying y is always equals to 2. So to give you a graph, y is always equals to 2. All right. So that means when the slope is equals to 0 of a straight line is equals to 0, we have a horizontal line when the slope is equals to 0. All right. So this is how we write the function of uniform distribution. So for uniform distribution, I need two numbers. One is the lower limit. 2 is b, that is upper limit. And x is a continuous random variable. All right. So here is the function of uniform distribution. F of x is equals to 1 divided by the maximum minus minimum, or you can say the upper limit minus lower limit is always 1 divided by b minus a. When you solve a uniform distribution problem, all you have to look for is the lower limit and the upper limit, a small number and a big number. And then to set up the function, you have f of x equals to 1 divided by b minus a, and then this function has a name. We call this probability density function. In short, we call this a PDF. All right. So this is the PDF of uniform distribution. A is the lower limit, B is the upper limit. And then how do you graph that? There is no x, right? So there is no slope. What do I mean by there is no slope? A and B, they are real numbers. So 1 minus 1 divided by b minus a is actually a fraction, just 1 divided by a number. There is no x in it. So the graph of uniform distribution is defined between x equals to a and x equals to b. We have one horizontal line between a and b, and then the height is 1 divided by b minus a. So if you line them up, use a dashed line, the graph of uniform distribution looks like a rectangle, right? So back to discrete random variable. For discrete random variable, what do we have? For discrete random variable, let's go back to this place. I will change the color a little bit. So we remember this. We have a table. We have a discrete random variable x. X has some distinct value, right? And then each value of x, so let's say x1, x2, has a probability. So there are probability. And then the sum of all the probabilities is equals to 1. Okay, so in uniform distribution, we don't have a table anymore. So we are not able to draw a table like this one. What is this table called? This table is called the probability distribution of discrete random variable x. Again, probability distribution of discrete random variable x is a discrete random variable. To write the probability distribution, you must use a table. Back to uniform distribution. In uniform distribution, this x is a continuous random variable. X is any value between a and b. So there is no more table. Why? Because, well, let's say a is equals to 1 and b is equals to 10. X can be any number between 1 and 10, like 5, 6.05, 6.001. There are infinitely many numbers between 1 and 10. So I am not able to give you a table anymore. Instead of drawing a green table, I have to give you a graph. Because another way to say this is the area is not countable. Area is not countable. Back to the green table. The sum of all the probabilities is equals to 1. In the uniform distribution, the area of the rectangle must be equal to 1. By the way, how do you find the area of a rectangle? We take the base times height, right? So the base is b minus a. That is the length of the base. And then the height is 1 divided by b minus a. So that is equals to 1. Area of this rectangle is equals to 1. Just like the area of this probability distribution is equals to 1. The only difference is this x we can count. This x, this one, we are not able to count because x can be any value between a and b, and area is not countable. All right? Okay, let me give you more formulas. This discrete random variable has expected value, right? Variance and standard deviation. Uniform distribution has its own formulas to find the expected value. So which is expected value that equals to 1/2 times a plus b. And then variance is equals to 1/12 times b minus a squared. And then standard deviation is the square root of variance. There is really not a formula for standard deviation. It's just the square root of the variance, because when you find the variance, you square the unit as well. Okay, before we get into any probability questions, we have to review some adverbs in statistics. So let me switch colors for that. So let's say x is a random variable. Any random variable, it can be discrete or continuous. It's a random variable. So one adverb that you see all the time is x is at most n. What is at most n mean? At most n means the maximum is n, including n itself. So this is x less than or equal to n. This is very important. You have this, you see these things in probabilities all the time. And then the next one is at least. At least n. At least means n or above. So that is x greater than or equal to n, including the n, right? And then we have a more than. That is straightforward. More than and less than. This is easy. Greater than n, less than n, not including n itself, right? And then we have a no more than. What is no more than? The opposite of greater than, so we have a more than n, but this one we have a no in front of it. No more than is the opposite, less than or equal to n. So that means no less than n is x greater than or equal to n, just the opposite of less than. And then we have a between a and b, a and b, one inclusive, one exclusive, inclusive, one exclusive. Inclusive means including a, including b. Exclusive means you take away the equal. If you say n is between a and b, then feel free to change that to an n. Or using x is fine. As long as your inequality symbol is fine, you'll be okay. Alright, so that is the introduction of the uniform distribution. So in the next video, I will show you the first example of uniform distribution.